Do you know the Python data structures? Lists were discussed in last episode, and now let's move on to tuples. The tuples are most alike lists with few subtle differences. Watch till the end of the video to know all about tuples and their differences with lists.
Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will briefly cover all the data structure that are available in Python. These are already available. You don't have to construct them. You can use it readily once you know their usage. In today's episode, we will talk about tuples. These tuples are heterogeneous in nature, unlike the list, which is a homogeneous in nature. Next, we will talk about the accessing and concatenation operation on tuples. So these are basically lists with special ability and restriction also. Next, we will talk about the unpacking method and iterating method on tuples. Next, for the unpacking, we will talk about how to unpack any unknown number of elements in a tuple. So this is for known and this is for unknown. We will show you two methods of unpacking. Finally, we will demonstrate the slicing method on tuples, which you have already seen in case of list, and you know how the slicing work, and the same thing and some additional features will be disclosed in the last slide. So that's the menu for today. Without any further delay, let's begin. Data structure in Python. So here briefly we give you a table. The table starts here, the data structure. First element list, which we have discussed in last episode. Next one is the tuple, which we are going to discuss today. And there are two rest of the things that we are going to discuss in upcoming episode, that is set and dictionary. So today we will focus on tuple. We are done here. Let's move on to the next slide. Tuples, heterogeneous nature. As we do, we are going through examples here. The first example here of the tuple. Through this example, you will understand that tuples are basically a special type of list with some restriction and features. The first line here is hashbang used in Python 3. This is nothing but our Python interpreter, and obviously this code is portable, so you can use this code in Windows. If you remove this, this is needed for the Linux. Next, we have the tuple t, and here how it is written. You can see 1, 2, 3, 4, 5 is the first element, next element is this, and the third element is this. So you can see this is number and this is some string. So the elements of the tuple are heterogeneous, which we have just mentioned here. Next, we print the length of the tuple t here to this print command. Len we have discussed in last episode, which you can use over the list, and now you can see you can use it over the tuples too. Next, the tuples may be nested and can contain list. Since this is heterogeneous in nature, it can contain a list too. So you can see tuple is not a list. It's a specially featured data structure which looks like a list, but it has some more features and some restrictions. Next, here you can see this is our tuple, the next tuple, where the first element is a tuple itself, t, which we have defined earlier. The next element here is again a list of numbers, that is 1, 2, 3, 4, 5. Another list is there of orange, apple, lychee, pear. So these are the fruits and we have them inside the tuple. So you can see that how the heterogeneous nature can be in various forms in this example. Next, we use the print command to print the tuple and length of the tuple. Since this has to be expanded into this, we use here u to print the entire thing. Otherwise, the thing is visible to us. But how this comes here while it is expanded, we will see. Now, this is our code, and another thing here I would like to mention is that tuples are immutable, so they cannot be interchanged. Okay, so modification directly is not possible. Unlike list, this is the special restriction in tuple, which I have talked a couple of times from the beginning. So you see the restriction here. Here, once we run the code, we get this output. So this is the first print command, which prints our initial tuple here, and you can see the len operator here keeps the number of elements, that is 3. Once the code goes further, this print command is executed and it prints u. Okay, so the first element here, you can see this is nothing but our first tuple, right? And the next element is a list, which is here. and the next element is another list which is here. So you can see the heterogeneous nature of the tuple here. With the first one you see explicit the single element which is heterogeneous, this and these are of two different types, that is number and string. And here you can see the nested elements are even further different type. So you can see the versatility of the heterogeneous nature here in this example. Here you can see the length calculated by this particular function len of this tuple. Since this is nested, this is element 1, element 2 and this is element 3. So there are 3 elements. So it is treating this, this and this as a single element, and hence this is nesting. It is not counting 1, 2, 3, 4, 5, 6 and not like this. It is counting 1, 2 and 3, that is 3 elements. So here we are done talking about the basics of the tuples and its heterogeneous nature, which makes it very different from the list. So let us move on to the next slide. Accessing and concatenation of tuples. Here let us demonstrate these methods through the example. Here goes the first line of our code, which is nothing but our interpreter. Next we have the comment creating tuples. The first tuple 1 is 1, 2, 3. Next tuple is apple, banana, orange. And tuple 3 Mercury, Venus, Mars. So you can see these are 3 different kind of data, although this is string as a type, but the nature of the string is different. Here it is fruits, here it is the planets. Next, accessing the tuple elements. Here we will access each individual tuple element like this. How to do that? This is very similar to the list. Right, first we write the print command. Here first we print the element of tuple 1, the first element, and here it is tuple 1, then 0. As we put the index here, it gives the first element. Next, second element of tuple 2, so tuple 2 is this, the second element tuple 2 is accessed by index 1. Next, we have the third element of tuple 3, that is here is tuple 3 and we put index 2 and it accesses the third element of tuple 3. Now we talk about concatenation of tuples. So first accessing is done. Now let us focus on the concatenation. Tuple 4 is equal to tuple 1 plus tuple 2 plus tuple 3. So this will concatenate, that means this will make all these tuples to pack together into another tuple, that is tuple 4. So here we print the concatenated tuple, that is tuple 4. Once we execute this code, we see the below output. So here you can see the first element of tuple 1, which is this one. Second element of tuple 2 is this, which is nothing but this one. And third element of tuple 3, which is nothing but this one. And the fourth one, the concatenated tuple, that is the addition of all these tuples 1, 2 and 3. So here 1, 2 and 3, apple, banana, orange, Mercury. So this code is available for download from the GitHub. Link is provided in the description. The earlier code is also available. You can download this code and try to print the len of this tuple 4. Okay. Add that line of the len from the previous code and print it. So we have done talking about the accessing and concatenation of tuple in this slide, and the code is downloadable so that you can use it, modify it and do the trial and errors. We are done here. Let's move on to the next slide. Unpacking or iterating on tuples. Here goes our code. The first line of the code is nothing but the interpreter. The next we are talking about creating of tuples. First tuple 1, next tuple 2, third one is tuple 3. These are very same from the previous example. So these 3 tuples. Now here we print the length of the tuple 3, that is len tuple 3. Now let us start the unpacking. We write A, B, C, and in the right hand side we write tuple 3. Now why we have print len here, you will understand, because it is 3 we know already, but in case it is unknown you have to print the length first and then do the things. So the first variable A will contain this one, B will contain this one and C will contain this one. So this is the method of unpacking. So here we print the unpacked values of tuple 1 are A, B, C. So now the tuple 3 is unpacked into these 3 variables and we are printing them. Iterating over a tuple. So talking about the unpacking is done. Now we move on to the next part, that is iterating on tuple. So here elements of tuple 2 we will iterate on this one. How to iterate? We write a for loop. So for item in tuple 2, in case you are unfamiliar with the for syntax, we have already one episode on the loops. Please go to the playlist and watch that particular episode. and we simply print the item that we get as we iterate, right? So this is the method of iterating over a tuple. That means we are accessing the elements one by one. Now, once we execute this code, the output comes like this. So the first print command gives the length of the tuple, that is 3, and next we have the unpacked variables are Mercury goes to A, Venus goes to B, and Mars goes to C. So these are printed. Now elements of tuple 2. Now in the next part, in the iteration part, the elements of tuple 2 are apple, banana, and orange. So this way you can either unpack the tuples or you can iterate over the elements of a tuple. Here we have chosen the tuple with very small number of elements, but in real case this can go in a very huge number. That's why the data structures are very important. So we are done talking here. Let's move on to the next slide. Now, in last slide, we have talked about the unpacking method for known number of elements. In case the number is unknown, which is a very realistic case in case you are parsing some file and you have populated all the data in tuples, right? So in that case, this unpacking method will be a very realistic one. So here goes our code. The first line is nothing but our Python interpreter. Next, we have the tuple assignment. The numbers here, this is our tuple, and here we have 1 to 10, the integers starting from 1 ending at 10. Next, we have the method of unpacking using the wildcard. Let us see, we have the first, we have the second, and we have the remaining. And you can see the star is here. This is our wildcard. And on the right hand side, we have numbers. So you can relate with the previous example. First, we'll fetch this. The second will fetch this. And the rest will be fetched into this one. So this will become a tuple and it will contain these elements. Displaying the unpacked values. We write print first, the first one which is unpacked. The first is the variable. Earlier we used single alphabet variable, but here we are using names, that is strings. Next we have unpacked 2. Next we have unpacked as a tuple. First, second, and remaining. Okay. So this is the unpacking method here we have discussed, and this is for unknown, and this is a very realistic case because on the fly when you are getting a tuple, you don't know how many elements are there, you can unpack in this method. And once we run this code, we get this output. So you can see the first one belongs to 1, the first element, the second one belongs to the second element, and here you can see the remaining is nothing but the rest of the tuple, which is again picked up as a tuple. So this is the unpacking method that we have talked about in the previous slide, and this slide we have talked about the unpacking method, and we are done here. Let's move on to the next slide. Now in this slide, talk about the slicing method to get some new tuples from an existing tuple. And this is not unpacking, this is a slicing method which we already discussed in list, and we'll see how that is done for the tuples. Here goes our code, and this is the first line of the code, which is nothing but our Python interpreter. Next, we have the tuples starting here with numbers from 1 to 10 we have in this tuple. Next, we are slicing the tuple. The first slice is numbers, then 2:5. That means we are starting from index 2 up to 4. This is exclusive. So this is the first tuple. The next tuple is tuple 2. That is numbers 4 : then nothing. Right. This means we start from index 4 up to the end. Next, again we do the slicing here. Numbers. This is the :3. That means we start from the very beginning and we run up to index 2 exclusive. Next, our tuple 4 is numbers, then 1:9:2. Now, where does these 2 comes from? This is nothing but a step of 2, and it is starting from 1 index up to 8 and with a step of 2. Now here displaying the slice tuples, we write the first print command, second print command, third one, and the fourth one. For all these tuples, we print them separately, and once we execute this code, we get this. The first one is 2 to 5. That is, here you can see the 2 to 5 is this 3, 4, 5, which is here. The next one is from 4 up to this. So this is 4 and up to this. That means up to 10. So you can see this has come here. So this is another slide. Another one here is :3. So it is starting from the beginning and it is stopping at here. So you can see this part is here. And the very interesting slicing is the fourth one, where we start from 1 and go up to 8, right? But with a step of 2, that means we are jumping one element. So here we are starting from here and jumping and going up to here, right? With a step of 2. So we have 2, then 4, then 6, then 8. So the even numbers, and we are stopping here at 8 as this is our stopping index, right? We are done with the slicing method of the tuples. This code and all the codes shown in this episode are available for download from the GitHub. Download links of the individual files are provided in the description. So here we have done talking. Let's move on to the next slide. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislike, put that as in words in the comment section down below. And bye for today.